is Connolly. I started making math videos for my 5th grade students and decided I wanted everyone to be able to learn math while they were stuck at home. So that's why I started making videos for other grade levels. If you have any topic you want me to cover, connollymathathome@gmail.com. And please be sure to like, subscribe, and share so that we can get as many students learning as possible during this time. So today we are going to talk about comparing fractions. And I'm going to show you some strategies that we use for comparing fractions, and then also how we form what's called a conjecture at the end. And I'll explain that when we get there. So let's look at a couple different fractions that we're going to compare. During this video, I'm going to be thinking about fractions that have the same denominator. Okay, so fractions with the same denominator. So let's think about comparing 3/4 and 2/4. Okay, so one way that we might think about comparing fractions is by drawing an area model. And when we do the area model, when we're comparing fractions, the whole needs to be the same exact size. Okay, so what do I mean by that? I mean that when I'm going to represent 3/4 on an area model, and I'm going to compare it to 2/4, those wholes need to be the same exact size. Why? Because if I was comparing 3/4 on here to 2/4 on there, that's not the same size whole that we'd be starting with, so our comparison would not be accurate. So what we need to think about is using the same size whole to compare fractions. Okay, so let's think about 3/4 compared to 2/4, and let's see what we notice when we do the area model. Okay, so I'm going to shade in 3/4 here. I'm going to represent 3/4 on the area model. And then I'm going to represent 2/4 on this area model. And I'm wondering if there's any noticings right now about which one is larger. You can clearly see from the area model representation that 3/4 is larger than 2/4. Okay, and I want you thinking about the size of the pieces too. Is this piece the same size as this piece? Is this piece the same size as this piece? Is this piece the same size as this one? Is this one the same size? Are we dealing with the same size pieces? That's something I want you to think about. So we can clearly see that 3/4 is greater than 2/4 on the area model representation. And I'm also going to show you another way that we compare fractions is on a number line. And when we're comparing the two fractions, if you use two different number lines, you still need to be thinking about the same size wholes. So I'm not going to make one number line start over here and this be 0 and go this long and be 1. We want to be starting with the same size wholes. So anytime you're comparing fractions, you're always starting with the same size wholes in your representation. So closest that you can get to that. So I want to represent fourths on both of my number lines. So I'm going to represent 1/4, 2/4, 3/4, and we discovered in one of my last videos that 1 whole is equivalent to 4/4. Okay, sometimes you can compare on the same number line, but when we're getting started, it's easy to draw 2 and look at the comparison. So if I'm going to show 3/4 on this number line, I'm going to mark it there. And if I'm going to show 2/4 on this number line, I'm going to mark it there. And we can clearly see that the distance from 0 to 3/4 is further than the distance from 0 to 2/4. So, 2 things that we did. We represented on the area model. That's one way we can compare fractions. And the other way we can compare fractions is on the number line, making sure that we pay attention to the same size whole. If you're making a comparison, you have to draw the same size whole first, then represent both fractions, and then see which one is greater. Okay? So let me just put this over here. 3/4 is greater than 2/4. And I want us to see if we can come up with a conjecture, an opinion, about what happens every time, even though we can't possibly explore every single situation. Okay, so we're going to be thinking about each time we compare when our denominators are the same. Okay, so that was one set of the denominator being the bottom number here. The denominator was the same, And we found that 3/4 is greater than 2/4 in both of our representations. Okay, so let's try a different denominator and see if it works there. So let's think about, if we're thinking about 6. So is 2/6 greater than 4/6, or is 4/6 greater than 2/6? Let's take a peek. So I was talking about the same size whole, so that is what you need to do, okay? Paying as much attention as possible. I like to put them right underneath each other so that I can make sure I'm drawing the same exact width, and then I kind of try to eyeball the length there, so try to get them the same. Okay, and we're representing 6, so I'm going to represent it like this. Oh, that is not going to give us the same size pieces. Remember, we want to get as accurate as possible, especially if we're doing a comparison. Okay, and I'm going to shade in 2/6, and then I'm going to compare that to 4/6. So, what are you noticing? Think about what you're noticing. We have the same size whole. This is our area model representation. We can clearly see that 4/6 is greater than 2/6. Okay, and let's check that out on the number line. Again, paying attention to the same size whole. So 0 to 1, 0 to 1. If you haven't watched my number line video yet, it's helpful to think about how we represent fractions. So make sure you check that out. So I'm going to label, and I hope that you're also noticing I'm not just eyeballing the number line and saying, oh, I think 2/6 is right here. I'm actually partitioning it perfectly, even, well, as close to perfect as possible. Equal parts, 6 equal parts, labeling them all the way, and then I make my comparison there. So I'm thinking about 2/6 compared to 4/6. And then I can clearly see again on our number line that the distance between 0 and 4/6, so the distance from here to here, is further and greater than the distance from 0 to 2/6. Okay, so when I'm thinking about this, this would read 2/6 is less than 4/6. And just a reminder, I like to think about this as alligator teeth. The alligator teeth are facing the greater fraction because it's hungry, it wants more. Okay, over here you see that the teeth face the greater fraction. So if you're having trouble remembering which way the symbol greater than or less than goes, just make sure that the alligator is always chomping on the greater number, the greater fraction, whatever you're comparing. Okay, so again, what did we do? We made the same size whole. 2/6 and 4/6, we shaded it in. It's clear that 4/6 is greater. And then we did the number line. It's clear that 4/6 is a further distance from 0 than 2/6. Okay, so I'm going to write it over here. I'll write the larger fraction first again so that we can start thinking about what's happening. Okay, so our comparisons are over here. And we'll do one more. And I want you thinking about what happens when we're comparing fractions with the same denominator. Is there a way we will always know which one is greater? So keep on thinking about that. Okay, so let's do, so we did 4, so we did 6. Let's do 1/3 versus 2/3. So I'm going to make the same size whole. 1/3. Make these as accurate as possible. My thirds are not the same size, so I'm just going to do a little bit of adjusting the best that I can. It doesn't have to be perfect. But we have 1/3, and then we have 2/3. And you should be thinking about which one is greater. Okay, so we said the same size whole. I shaded in 1/3 here, I shaded in 2/3 here. Okay, on the number line, what does that look like? Well, we make the same size whole. 0, 1, 0 to 1. We split it into 3 equal parts, 1, 2, 3, label. We're going to label here. If you want to compare on the same number line, that's totally fine. but then we're thinking about 1/3 is here, that's the distance from 0, and 2/3 is here. Which one has a greater distance to 0? We can tell it's 2/3. Okay, so again, alligator eats that way, and this reads 1/3 is less than 2/3. So, now it's time to form our conjecture. So, we are going to form an opinion about what happens every time we compare two fractions that have the same denominator. So that's what I've been focusing on this whole time. What happens when we're comparing two fractions with the same denominator? So, if you are you're probably at home, I want you thinking about what happens every single time. So I'm going to start writing out what the conjecture is going to start like at the beginning. So when two fractions have the same denominator, what is happening? Sorry, I'm ran out of space. What is happening when two fractions have the same denominator? What's really important, if two fractions have the same denominator, their pieces are the same exact size. So let me just show you one more time with the thirds, okay? So if I'm thinking about thirds, both of my fractions have the same size pieces. These pieces for 2/3 were the same as the size pieces for 1/3. So since we're comparing two fractions that have the same size pieces, because they have the same denominator, the one with the greater numerator is always going to be bigger. Why? Because we're taking two of those same size pieces versus one of those same size pieces. Here, we were taking 4 of those 6. They were the same size pieces. Let's show it one more time. Okay, 1, 2, 3. There, we were taking 4 6 compared to the same size pieces, and we were only taking 2 of them. So when we're comparing the fractions with the same size pieces, the one that we're taking more of the pieces is going to be greater. So the one with the greater numerator will be greater. So let's finish this conjecture so that we totally understand. So when two fractions have the same denominator, the fraction with the greater numerator, and greater means larger, with the greater numerator, is greater. Sorry, this is a very small board. Okay, so then once you form a conjecture, we have to think, is this true all the time? So we're going to just look at 2 more quick examples, and you're going to tell, well, I wish you were here to tell me what you think. We're going to think about it together. So when two fractions have the same denominator, the fraction with the greater numerator is greater. So let's see if that is true all of the time. Let's think about 4/5 and 2/5. Do we have the same size pieces? Are we cutting the hole into the same size pieces? Oh, I guess I'm making a long skinny rectangle this time. So I made them the same size pieces because 4/5 and 2/5 have the same denominator, so we get the same size pieces. 4/5 has a greater numerator. Will it be greater than 2/5? And it is. So this time, and we're going to try one more time, and all the other times that we've done this, we have the same denominator, so we know we're dealing with the same size pieces. So when two fractions have the same denominator, the fraction with the greater numerator is greater. So which one has the greater numerator? 4/5 or 2/5? The greater numerator is the 4/5, so that one is greater. Our conjecture is continuing to be proven true. So we'll do just one more and make sure that we definitely got it. Okay? So let's think about 4/7 and 5/7. I'm going to show them on one number line because I haven't done that yet. So Sevenths, that's hard. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Some of these are not perfectly the same size, but we're doing our best here. Okay, so 1 7th, 2 7ths, 3 7ths. I don't like how far away that one is. 4 7ths, 5 7ths, 6 7ths, 7 7ths as a whole. We're comparing on the same size whole because I'm doing it in the same representation. 4 7ths is here, 5 7ths is here. So let's see if our conjecture is true. When two fractions have the same denominator. Do they have the same denominator? Yes. They have the same size pieces? Of course, they're on the same number line. The fraction with the greater numerator is greater. So, which one is greater? 5 7ths or 4 7ths? You can clearly see that 5 7ths has a greater distance from 0. So, the fraction with the greater numerator is greater. Okay, so let's review what you learned in this lesson. First, to compare fractions, we draw a representation. You have the area model or the number line. What do you need to remember? That you have to start with the same size whole when you're comparing fractions. Not negotiable, you have to do it. Okay, then we discovered that when we're dealing with the same size pieces, when we're dealing with the same denominator, when you compare fractions, the one where you're taking more pieces, the numerator is greater, the one where you're taking more pieces is going to be the greater fraction every time. Okay, so while we do rely on the area model and the number line, it's really important that you start to form these conjectures and remember them and apply them to your work. So if you are comparing fractions today, I want you to think about this. Are the denominators the same? Because there's more conjectures than this, so stay tuned because there's a lot more videos coming. When two fractions have the same denominator, the fraction with the greater numerator is greater. And if you have a little notebook, you might want to start a little page about conjectures and jot them down because I'm going to give you a lot of them. Okay? So, I hope this was helpful. Remember, you're drawing the area model, same size whole. You're drawing the number line with the same size whole. And then we're comparing fractions based on a representation. But we also now know one conjecture, that when the denominators are the same, the one with the greater numerator is greater. Okay? So keep that conjecture in mind, and we're about to learn a lot more. Okay? Bye.